And let's review factoring a sum of squares. So I'm going to start you out kind of giving you a walkthrough, and I'm going to go through it in detail. It's going to kind of list out the step-by-step, kind of like the behind the scenes. Once we get through a few of these, we should be able just to jump right in and factor. So if you look here, we have x squared plus y squared. Now, x squared is a perfect square and y squared is a perfect square. In 2-3, we factored the difference of squares, which was a really quick, easy process, but we had a minus sign here. Now we have a plus. So let's take a look at this. Can we turn this into difference of two squares? Well, if you think about it, I could rewrite this as x squared minus a negative y squared. Well, I can break down negative y squared even further. So let's take a look at this. Remember, negative y squared is the same as negative 1 times y squared. And then we could break it down again. Well, we also know, don't forget, I squared equals negative 1. So let me substitute I squared in for negative 1. Okay, now I can combine this, and I'm going to have y times I squared. And now notice I don't have a negative up front anymore. So what I can do, because this is my difference of squares that I wanted, but remember, to take the difference of squares, you'd have to take the square root, and that would give me a negative. So I can substitute this for this. They are equivalent. So I would have x squared minus yi squared. And then when I would go to factor this, I have that subtraction. X squared is a perfect square, and yi squared is a perfect square. So I would drop in my parentheses. My signs will be opposite. Square root of x squared is x. And the square root of yi squared is yi. Okay, so that's kind of the behind the scenes of what is going on. Let's do B, and we're going to kind of cut it back just a little bit. And then when we do C, we're just going to jump right into it. So right off the bat, I can see 12 is not a perfect square and 3 is not a perfect square. However, I can also see I have a GCF of 3. 12x squared is divisible by 3 and 3 is divisible by 3. So let's factor out that GCF. So I'm going to get 3 times 4x squared plus 1. Okay, that's better. So 4x squared is a perfect square, and 1 is a perfect square. We have a sum of squares. I'm going to go ahead, let's break this down again. 3 times 4x squared, I want to write this as the difference of squares, 4x squared minus a negative 1. Okay, so now I've got the subtraction that I need. And I also am going to remember I squared equals negative 1. So this can be written as 3 times 4x squared minus I squared, which is a perfect square. So now I have a perfect square here, and I have a perfect square here, and I have the subtraction, which is difference of squares. 3, I'm going to set up my parentheses. My signs are always going to be opposite. And the square root of 4x squared is 2x. And the square root of I squared is going to be I. And so this is my final answer. Now the next one, I'm just going to jump right into it. I think we see the pattern already. even though we have the plus here, we do end up with opposite signs, and it's just because we're going to have those complex numbers in there. So let's go right into this. I know x squared is a perfect square. I know 4 is a perfect square. However, I have this plus here. So there's one tiny difference between jumping from sum of squares, kind of using difference of squares to factor a sum of squares. I'm going to do the same thing that I do when I do difference of squares, and I'm going to put my parentheses in. This one we're going to solve too. And I know my signs are going to be opposite. Okay, so square root of x squared is x. I'm going to drop my x's in. And the square root of 4 is 2. So let me put a 2 in. Now here's the only difference. You're going to add an I. That is it. Just add an I. You can do this just like you would difference of squares, but if you have that plus there on your second term in each of your binomials, you're just going to add an I. So now let's solve for x, and again we'll use the zero product property. Set each factor equal to 0 and solve. X minus equals 0. Here I will need to subtract 2i from both sides. X equals a negative 2i, and here I would add 2x equals, or add 2i to both sides. And so there's my answers. X equals negative 2i and x equals positive 2i.